In this section, we're going to take a look at the stateful firewall implementation on the iOS devices, which is going to be the zone-based policy firewall, which is the replacement for what was known as CBAC. And of course, zone-based policy firewall adds more options, more functionality, and more scalability, more flexibility to the firewall implementation on the iOS devices. So it's a lot of the naming convention. You're gonna find the acronym to be ZBF, ZBPF, or ZPF. It's a lot of naming conventions out there. So it's both. All of them mean the same thing. So ZBPF or ZBF or whatever it means, zone-based policy firewall. So again, as the name states, is going to be a stateful firewall implementation on the iOS devices. And by the name, it means that the configuration and the design of this stateful firewall, it has to do with the zone concepts. So it's everything goes around what is known as to be a zone. So ZBPF supports, it's not only the stateful firewall implementation, it supports also deep packet inspection, just like the ASA firewall. It is based on the logical concept of security zones, and everything, all the firewall policies are going to be built around the security zone concept. Now, configuration-wise, this is a modular and hierarchical, let's say, implementation. For that reason, it makes use of what Cisco calls the C3PL, which is Cisco Common Classification, so triple C's policy language. So you can take a look. There's a Cisco document which actually defines what C3PL is. So looking on Cisco documentation for Cisco Common Classification policy language in here, and you're gonna find a lot more details about what this means. But of course, you're also gonna define what exactly this concept means on the iOS devices. As usual, we have to define the building blocks. So as I stated throughout the week and through all of my courses, you have to understand what what is the scope of the technology. We've defined that briefly. Stateful file, which would support for deep packet inspection, and then we have to define what are the building blocks, how they're connected one to another, and to to better visualize what is going to be the packet flow on the iOS firewall. So how do you match on traffic? What are the actions you can take on the traffic, and how do you enforce that firewall policy back and forth on the iOS devices? So the first step is going to be to define security zones. We're going to see exactly what that means. It's going to be just logical names. So you're going to define some security zones in there. Like for example, if you're going to implement stateful zone-based policy firewall on the iOS, and let's assume we're going to implement that on router 1. For example, and assuming that router 1 is like a border device, it could be that this network section connected to your router 1, whatever is reachable out in that direction, let's say this would be like our DMZ, one of our DMZs, and then this is going to likewise be what is connected on that direction is going to be another DMZ. So DMZ1 and DMZ2, but I'm gonna just call it DMZ because I'm gonna connect those two. Let's say I'm gonna connect those networks reachable in those directions in the same security zone. So I'm gonna end up saying that from router 1's point of view, whatever is routable in that direction, and in that direction is gonna be a member of the DMZ security zone. So zoning means you're going to logically segment the networks routable from the router's point of view into zones. It's a logical segmentation that you define. Then we're going to consider that, for example, whatever is routable in this direction, it is going to be, let's say, the inside or the LAN. So that's going to be my inside security zone. Whatever is reachable in that direction is going to be a member of the inside security zone. And of course, assuming that this router has also not a connection, like for example has a connection out on the internet, whatever is routable in that direction, assuming the router has not a connection in there, it is going to be my outside zone. And then what I'm going to end up doing, so once I logically define the zones, which means I logically segmented the network, the routable prefixes that router can route in between into zones, then I'm going to define firewall policies between those zones. So I'm going to define a firewall policy saying what traffic can flow between DMZ security zone to inside, for example, or to call it simpler, ideally you'll control what traffic can go from the inside to the DMZ. So what traffic can flow in that direction, and how do you control that traffic back and forth? What is the firewall policy? What traffic can flow from the internet to the DMZ zone? What traffic can flow from the inside, from the LAN side, to the internet, to the outside? And also what traffic can flow from the outside to the DMZ zone, because in the DMZ zone you have publicly available resources which you want them to be reachable from the internet. So you're going to define, like, this is going to be one firewall policy between the inside and the DMZ zone, source from the inside destined to the DMZ zone. The second firewall policy, traffic flowing from the outside to the DMZ zone. The third firewall policy, traffic flowing from the inside to the outside zone. And the fourth firewall policy, traffic flowing from the outside to the DMZ zone. So you logically segment the network into zones from the router's point of view, and then you're going to end up creating firewall policies controlling which traffic can flow between those zones, and how does the router, let's say, control that traffic back and forth between those zones. So we have to first define the zones. We logically segment the network as we want, and then we define the zones by names. Then we have to classify traffic to be inspected by the firewall. So likewise, you're gonna say, what traffic do I want to flow from the inside to the DMZ? I'm gonna have to classify that traffic. What traffic can flow from the inside to the DMZ, or from the inside to the outside, for example. Then you classify the traffic which you want the firewall to inspect or to control, not to inspect, because it can take out of actions. Then once you have matched on the traffic, you define the firewall policies for the classified traffic, which means you tell the router how to control that traffic back and forth. And then of course you enforce the firewall policy between the security zones. And finally, you have to attach the interfaces to security zones. Now, even though some documents out there state that the order might be different, this is the recommended order from my point of view, because as you're going to see on the end of this presentation, if you define the zones and then you attach the interfaces of the router to the zones before configuring the firewall policies, then you're going to end up blocking pretty much all traffic flowing back and forth to the router. Because as you're going to see at the end of the presentation, if there are no firewall policies defined, depending on how traffic flows in between, either traffic is going to be allowed by default or dropped by default. So you wouldn't want to define the zones and then attach the interfaces to the zones before configuring the firewall policies, because you may end up dropping traffic until you configure the firewall policies, and of course this is not what you would want in a production network. Now let's take it one by one. Let's see what is a zone. So what is exactly a zone and what are the types of zones? So we have two types of security zones. It's going to be something which is going to be a system predefined zone and a user defined zone. So the system predefined zone is defined by the router by default. The user defined zone, it means you're going to end up configuring those zones on the router. Now, there is only one system predefined zone. It's called the self zone. And that self zone is always, let's say, active. It cannot be changed or deleted. So you cannot change the name, you cannot delete it. Because this self zone, as the name implies, is myself, which me being the router, it is going to be responsible for traffic destined to or initiated by the router, which means management plane and control plane traffic. So the self zone controls all traffic destined to the router, which can be control plane traffic. Like for example, let's say it can be, I don't know, OSPF or EIGRP traffic. That's control plane traffic used to build the fib and the rib. And it also controls, the self zone also controls traffic management plane traffic, which means either traffic destined to router 1 or source from router 1. But for example, management plane would mean traffic like CCNP or NTP or syslog. So whatever has to do with managing the router, or telnet or SSH or everything else. So bottom line is that the self zone is in control with traffic destined to the router or initiated by the router, which we have two types of such traffic. It's going to be either control plane traffic or management plane traffic. So that zone is by default active. It's by default, let's say it exists on the router, it is configured, but it's not active because zone-based policy firewall is not configured, is not active by default, which means that zone being there to begin with achieves nothing. It is just present in there and it's going to take effect once you actually configure zone-based policy firewall on the router. The user-defined zones, the name is going to be assigned by yourself, which as I did before is going to be a name of DMZ or outside or inside or whatever you find a relevant name. And the user-defined zones are going to control traffic transit in the router, which means data plane traffic. So what that means is that, for example, based on the building blocks, if for example, if this is the router in here, and let's say I define a zone of inside. And I attach this interface of the router to that security zone. Because the last step was to actually bind interfaces of the router, physical interfaces to the security zones. If I bind that interface to the security zone of inside, it means that all traffic routable in that direction is going to be a member of the inside zone. And then if we define a zone called DMZ, and we attach this physical interface of the router to the DMZ zone, it means that all traffic routable in that direction is going to be a member of the DMZ zone. So now what it means is, for example, that if I have a packet flowing this way, in this direction, traffic is going to flow from the inside to the DMZ zone. And as you can see, this is traffic transit in the router, is data plane traffic. The router is going to just route the packets back and forth and do with the packets whatever the firewall policy, which I'm going to configure, tells the router to do with the packet. Because that packet is not destined to the router, it's transiting the router. But for example, if we have a traffic flow like this, I'm going to use the color of orange. If traffic goes in this direction, but is destined to router 1, control plane or management plane, let's say it's going to be a telnet session. This is going to be a firewall policy from the inside, because traffic comes inbound on the inside interface zone and is destined to the self zone. This in the self zone because this traffic is destined to the router. So when you define traffic policies which contain the self zone, it means that has to do with traffic destined to the router or initiated by the router. That's going to be the orange traffic flow. When you define firewall policies for traffic transiting the router, like from the inside zone to the DMZ zone, then that's going to be for data plane traffic, not for control plane or management plane traffic. So firewall policies between user-defined zones are going to control transiting traffic. Firewall policies between a user-defined zone and the self zone are going to control plane traffic and management plane traffic to and from the router. Now let's go to the second block, classifying the traffic, because we want to first after we've defined the zones, we have to tell the router, okay, which traffic do I want the router to inspect to control to the from the firewall point of view. So to classify the traffic, this requires the use of inspect type class maps, which we have two types of inspect type class maps. We have a layer 4 class map, which is used for traffic classification, which means like just matching on a traffic which we want to take some firewall actions, like match on the traffic however way we can. We're gonna see in a couple how we can match on the traffic. And also you have the layer 7 policy map, which is used for deep packet inspection. So you're gonna define a layer 7 class map of type inspect if you want the firewall to inspect, or to, let's say, if you want the firewall to do deep packet inspection, which means look at the layer 7 headers of that packet. And for example, just like it was the case with the ASA MPF, for example, you might want the router, as it sees HTTP traffic flowing from the inside zone to the DMZ zone. If it's destined to www.xyz.com, you might want the router to drop that traffic. But if it's HTTP traffic between inside and DMZ, but it's destined to www.cisco.com, you may want to allow that traffic you may want the firewall to allow that traffic back and forth. So layer 7 policy maps class maps are going to be used only if you want to do deep packet inspection. Otherwise, if you just want to match on the traffic which you want to control through the zone-based policy firewall, you're going to make use of layer 4 class maps. Now, layer 4 class maps can classify traffic based on out of access list or protocol. So in the class map of type inspect of layer 4, you're gonna put in here match statement matching on a protocol or on the access list. So that's the way you can tell the router which traffic it has to classify for that firewall policy. Other option is going to be to include in a class map other class maps, because that's what I said, that this is hierarchical configuration. Because within a class map, you can match on the traffic by saying match access list or match protocol, or you can also say match class map, because you can do class map nesting. So that's for scalability reasons. Now, the layer 4 class map may contain, so one class map, of course, may contain one or multiple classification criteria. So that's the class map can be defined as a match any, which means you're going to end up having a OR operation between the entries in the class map. Like for example, if I define a class map of type match any, and I say match protocol HTTP and match protocol FTP and match protocol SMTP, then the file is going to match, the traffic flowing to the file is going to match on that class map if the traffic is out of HTTP, out of FTP, out of SMTP. Doesn't have to be all of them at the same time. Well, if you define the class map as a match all, which means is the end operation, and if you don't specify the type of class map, is going to be by default a match all. That means that if you would configure in the class map multiple conditions, the router is going to match on that class map with the traffic if all conditions, if all match statements in the class map are being successfully met or matched. Once we've defined, we match on the traffic using the layer 4 class map, then we have to tell the router what to do with that traffic. How do you want the firewall to actually control that traffic? And that's going to be using policy maps, likewise of type inspect, and likewise we have two types of policy maps, layer 4 policy maps and layer 7 policy maps. So you're going to configure, if you want to do deep packet inspection, you're going to have to configure a layer 7 policy map, and calling the policy map the class map of layer 7. If you want just to do regular stateful firewall configuration, so you want the router to actually allow the packet or drop the packet or inspect or statefully inspect the session, you're going to end up configuring a layer 4 policy map in there. So layer 4 policy maps are gonna call in layer 4 class maps. Layer 7 policy maps are gonna call in layer 7 class maps. Now, one layer 4 policy map can reference multiple layer 4 class maps, and once traffic is gonna flow to the router is going to evaluate the class maps from under the policy map in the order of configuration. And for each class map, a firewall action needs to be defined. So when you define the policy map of type inspect of layer 4, you're going to say, for this traffic of this class map, what do I want the firewall to do with that traffic? That's going to be one class map. For the second class map, which it's another kind of traffic, what do you want the router to do with that traffic? For the third class map, which is another kind of traffic, what do you want the router to do with that traffic? And the router processes the class maps in the policy map top down, just like in an access list, and is going to stop on the first successful match on the first class map. Now, if the traffic doesn't match on any of the configured class maps within the policy map, it's going to match on the default class map, which is called class default, and that has a default action of drop. And this makes a lot of sense because clearly, for example, if you look at our diagram in here, taking this example with those zones in there inside an DMZ, let's say that you configure a class map. That's going to be one block. So block number 1, you configure the class map. Let me use red to be visible better. So you define a class map, a C map, and let's say you match on protocol, you match on HTTP traffic. Then you define a policy map. And in the policy map, what you do is you bind the configured class map, which matches on HTTP traffic, and you tell the router what action you bind in there your configured class map, and you tell the router what action do you want the router to do with that traffic, with the HTTP traffic. You're going to see what the actions are in there. So you specify the firewall action. What do you want the router to do with that HTTP traffic? Which means that if traffic flows through the router which is not HTTP, it's let's say FTP, it is going to match on the default class map of class default. So class map of type default, which has a default action of drop. So we're going to look at what are the available actions that you can define in a policy map for each class map. But the default class map has by default a action of drop. And this makes sense because the zone-based policy firewall is nothing else but an advanced and stateful mode of controlling packets through the router, as opposed to an access list which is stateless and doesn't have the features that a stateful firewall does. So like if in an access list you want to allow traffic if you would use an access list and you would want to allow traffic to flow from the inside to the DMZ, and you would allow only HTTP traffic in an access list. It means that HTTP traffic is going to be allowed in that direction, but then if the router is going to see, let's say, FTP traffic, the FTP traffic is going to match on the implicit deny IP any of the ACL, correct? So when you define the ACL, you configure in the ACL what traffic to be allowed, what traffic to be dropped, and then by default, whatever traffic doesn't match any of the ACL statements is going to match on the implicit deny IP any, which means it's going to be dropped. So the same thing happens with the zone-based policy firewall, meaning that looking back at our class mapping there, if traffic is going to flow in this direction inside DMZ and it's HTTP, the router is going to take the action as configured in here for that class map, because that's the HTTP matched. But if that traffic is going to be FTP, traffic is not going to match on my configured class map, because that class map matches only on HTTP traffic, which means traffic is going to match on the class default, which means traffic is going to be dropped by default. And this makes sense because clearly you want to control what traffic flows through the router and what actions do you take on that traffic. And you would want all other traffic which doesn't match your configuration to be dropped, correct? So that makes a lot of sense.